Welcome, everyone. My name's Kevin Coco. I'm with Because Learning, and we also have Lindsay Henderson here as a co-host and should be working the chat channel. And I wanted to say a big thanks also. We have some of the Astro School participants online, and we want to give a big shout out to ASE, Association of Space Explorers. And this is the association of all the people from the United States that have actually been in orbit in outer space. I have a great honor working with John David Bartow, one of the astronauts there, and we thank them a lot for helping us. So today we're going to be working with a really fun lesson that Lindsay put together, and it has combinations. So we're going to be using lasers and sensors, and we're creating an alarm. And I want to go through it. We'll go through the curriculum top to bottom, and then as I go there, hopefully I'll give you a little background and a couple of extra additions that you might be able to add to your in-class experience with students. So with that, I think I'm going to go ahead and share my screen, and we'll go right into the curriculum, and we'll bounce back from hands-on and screen and whatnot. Okay, so I think people can see my screen now. So what we're in right now is the Because Learning platform, and we're on this, it's called Mission Possible, an engineering an alarm. And really, you can see right here from the beginning, can you engineer an alarm with a laser pointer and a photoresistor? And that's kind of the opening. So what we're going to talk about is kind of through the engineering process through here, like let's kind of define the problem. And Lindsay has kind of a cool storyline here where somebody's taking something for your room and you want to make an alarm. And I've worked with students before and they're like, yeah, I need this. So it's kind of a fun kind of why are we building this here? And then we come up with like constraints and criteria. And for the constraints, it's like, what are our limitations? In engineering projects, we always have those limitations. That might be cost or time or money or heat or any one of these constraints. In our case, what we're saying is you have the things in your sensor kit, you have a laser pointer, maybe some tape and mirrors, and those are kind of your constraints. Then the criteria is going to be what is this going to do, and how would we judge that we successfully engineered this project? So in this case, it's going to be that we have a laser beam and a sensor, and when we break that beam, an alarm goes off. And so that's what we're going to be engineering towards. So when we look at it, the next step is like, before we get into it, I think it's a great idea to talk about like what this is and then generate ideas. And I think this is how a lot of engineering projects started, maybe like a whiteboard and engineers getting together and they come up with ideas and they fine tune this. And so I think this is a great step to actually take a pause and have them go to paper or whiteboard and actually draw like a model of what this looks like. And I think there's two kind of models you can make too, like physically, how's this thing going to be maybe set up? And then you can also go into maybe the model of the logic of how would this work? We have a laser and a sensor and an alarm, and how might we fundamentally even write that code? Okay, then we get into explore possibilities. And this is kind of like, I would consider this kind of like maybe in the engineering process, like prototyping parts out of the design. So taking small bite size or chunking down your problem. And we're looking right now at our first circuit. So this circuit is with the piezo speaker. And so this is in the kit. And what I'm going to do is I'm not going to spend a whole lot of time like actually doing all the individual wiring here, but what I will show is maybe some of the gotchas or things to think about or explanations that you might be able to do with your students when you're there. So what I'm going to show here, I just wanted to, I've got an annotate feature, see if I can figure this out here. So a couple things. So this guy right here is our resistor. This right here is our piezo. And in wiring, there's a couple things to know. The piezo is polar. So you have a positive and a negative, or an anode and a cathode. And you'll notice, so if your piezo is not buzzing, it's probably that it's maybe backwards. And when we look at it, we're getting our power from this pin 9 here. And that's going to be the anode or the positive, and that's going to be the longer pin on that piezo. Then the resistor is nonpolar, so it can work in either direction, so not a problem there. So what I'm going to do is get out of my anode. Okay, I'm going to get out of that, and we'll move on down. Oh, we got now that's just floating there. That's going to be pretty annoying. I will clear that. Okay. So we're here. I'm going to go ahead and we'll go down into the code. So a lot of times, like with our curriculum, you'll see a wiring diagram, and then you'll see a code block below. And you know, I'm kind of like a general student too. Is I just want to keep moving. I want to see something happen. So what I'm going to do is go ahead and I'm just going to run this right off the bat. So I'm going to switch to my overhead so you guys can see. I'm going to do this. I'm going to stop sharing that. I'm going to go to my overhead so you can see my circuit. Great. And then I'll go back to share my screen so we can see the code. Okay. So right now we're looking at this code block here. And real simple sketch. This is all the lines of code is 14 lines of code. And if we look at it here, we set up a pin. If we look before, we had that pin number 9. It's right here that is plugged into. And we're saying that's an output pin. And then we have a loop, and between these brackets here, it just runs this again and again and again. And what we're doing is we're taking that pin and we're turning it high or on for 500 microseconds, and then we turn it low for 500 microseconds. So kind of what do we think is going to happen with this? So I'm going to go ahead and just make sure I'm hooked up to that. So right here is our gear. This is where we can check for, are we hooked up to the serial port? So I do see we're already hooked up to Arduino. All these other settings are not really relevant for this time. And then I'm going to hit run on Arduino. So now it's taking this code, it's flashing it, and then it's sending it up, then it's sending it to the device. Okay. And now we can hear it buzzing. So we can hear it's buzzing right now. So this is basically, this is our basic alarm, our circuit. So a couple of things that I wanted to show. I'll get back in and I'll show this full screen. Let's see. I'm going to get out, stop sharing my screen. We'll look at the circuit. And there we go. So I'm full screen right now on my circuit. Great, perfect. Okay, so first of all, I wanted to keep this little label on here. If you could see it, what it says is remove seal after washing. So there's nothing in here that we would really wash, but this is actually just came from the manufacturer. And some of the circuits, what they'll do is actually, they'll be using a component, and then they actually put it in a wash to wash away some of the components when they're making a circuit board. But it can also be used as kind of a way to mute your circuit a little, and so it can get kind of loud. So there's a couple interesting things that I wanted to show with this little simple circuit here. So, you know, one of the things we'll show you a little bit later, but you know, it's like, God, this thing's driving me crazy. How would I turn it off? Well, really, any one of these wires really is just going to stop it from making a noise. And then a couple things we have that resistor there. There's kind of a fun, easy thing that we can do that also I think will allow the students to kind of get a better mental model of what this resistor does, this photoresistor. So we have this tiny photoresistor. This is what we're going to be using as our sensor for our laser project. So what I'm going to do is, this is a photoresistor, and then this is a 300 ohm resistor. What I'm going to do is I'm going to take that out, and I'm going to put in the photoresistor here. If I get on the right, it's kind of hard to hear. And I think actually if I give it, okay. So can you hear it going up? When I put light over that photoresistor, it gets louder and softer. So what do we think is happening there? So when the photoresistor gets light, its resistance is lowered, and so we're sending, we're getting more power to the volume, which is making that louder. So kind of a fun little thing we can play with there. One of the things that's kind of interesting too is, you know, we have this piezo here. It's like that. I talked about it earlier. I wanted to show this. So kind of hard to see this. See if I can get this. One of these legs is longer than the other, right? So the longer leg is the anode, and that's the one that's going to go to that positive. Same with an LED. So longer leg, same kind of concept. So what do you think would happen if I put, you know, if I put this in here into the same circuit too? Sure enough, we get a light. And does it dim? Sure enough, it does. And it should get, if I put the light on it, what do we think is going to happen? Maybe brighter? Sure. Let's see. Okay, cool. So a couple fun little additions that we have. So kind of the learning here is the photoresistor. It changes its resistance due to the light that hits the surface of it. And that's kind of the fundamental thing that we're going to be doing with our laser project here. Okay, so I'm going to go ahead and put this back in line. I'll show one more trick with this, and then we'll move on a little bit further into the exercise. Oh, here's one thing to note too, is so the resistor is actually, it's in the, you know, we still have that photoresistor in there, but it's actually not totally needed. What we can do is actually go in and we can go full volume, but we kind of put the resistor in to keep the classroom a little bit more manageable. So that is a possibility. I'm going to go ahead and throw this back in here. Okay, so we can hear that sound. What I'm going to go is I'm going to go ahead and share my screen. Okay. One thing I wanted to talk about too is we have a whole lesson on sound waves, and it's I think this is a kind of a fun piece of hardware to actually get on and do some hands-on experimentation. What we have here is like, this is delaying in microseconds, and if we wanted to make this like a lower frequency, we can actually change those delays, and let's give that a try. So we can hear we changed that pitch. So we took the sound wave, and now it's a longer sound wave, and we actually end up with a lower pitch. So students can play around that and get that exact pitch they want to have in their alarm project. Okay, so photoresistor, we talked a little bit about that. Some of the things that are kind of interesting with the photoresistor. So it's a very low cost, and why do we care about this? And where is this used? So one of the super common that almost everybody has an experience with would be street lights or outdoor lighting, or you get like the little solar lights that magically turn on at night. And what they're doing there is they have this small circuit set up with a photoresistor inside, and what it's looking for is that sun to kind of go down, and then it can see that the resistance changes, and then it can kick on a light. This can also be used in like really kind of neat, low-cost like sun trackers too. So if you think if you have two of these, and sometimes you have to put some type of blocker in between. As you rotate it towards the sun, you wait until you get kind of equal resistance readings from both of these sensors, so you can actually track the sun using these little photoresistors. Here are a couple of the questions that we have in here, like what happens when you replace a resistor with a photoresistor? We did that. Try putting your hand over it or shine a light, and that's where you can see like the change that happens there, that cause and effect. And now we're moving into our next circuit. Okay, so this is really the same circuit we had before, but we're adding a couple new items. So in here we have the photoresistor, and we're using it in a different way. Before, we just used it to replace that one resistor, just as an example. In this case, we're adding it to the circuit, and then we're connecting it with to the analog pin 0 here, and we're actually going to read the value off of that photoresistor. So I'm going to go ahead and change out the circuit right here. Okay. And kind of like, you know, just moving in so we have like the engineering challenge here, kind of talks about it. We have some code, and generally I just go to like, oh, I've got a circuit, I'm going to wire it up. I look good on my serial port, and then I'm going to hit run on Arduino. Okay, so we're flashing a new program over the serial port onto the Arduino, and I think this one is, yeah, set up. Okay, great. So what I'm gonna show right here, I'm just gonna quickly show. Let's see, do that. You see my screen still, right? Okay. I'm gonna go ahead and just go overhead. We will go to. Okay. So now you see the circuit. Great. So when you flash it, generally like something happens, and you know we have excitement. But actually, when this runs, really nothing seems to happen. But what happens is when we do give it light, and this has a flashlight, and then this also has a laser. And when the laser hits that photoresistor, you can see that it turns on right when I aim it at it. Okay. So if we think of our model, we want to have a laser beam and a sensor, and then when we break it, we want to have the alarm go on. So it almost has like a reverse logic, it seems, in this, and that's actually one of our challenges. So let's go ahead and check out the code. So I'm going to go ahead and share my screen, and let's look at the code. Great. So a little bit longer. What we have in here, so same type of thing, like we have pin 9 is set up for the photoresistor. But one of the things that we're doing here is we have the photoresistor value, and we're reading it here off that analog pin. And then in here, this is actually like printing that value out, and I'll show you that in a second. And then in here, we have a conditional statement. So this loop continues to go again and again and again. And it says, oh, this is really set up to go, in a nutshell, every second or 100 milliseconds, it will print out that photoresistor value. We'll talk about that later. Then it comes down to this conditional statement. If the photoresistor value is greater than 400, then it does something. And in this case, we've seen this code before. This is turning it high and low. And what it's really doing is just making a sound wave by pulsing that piezo buzzer. So in this case, it's like what we really want to have in this case is we really want to probably switch that from a greater than to a less than sign. And so this is editable code, and we can change it here. Before I do that, I think actually I'm going to go through and we'll talk about calibration. I think that's probably best. So I'm going to hit connect to the Arduino here, and in this case, before we showed some of this code right here, and what this is doing is it's printing the photoresistor value out, and then we have the logic set up so that we can get a graph of this. So right now we're graphing the photoresistor, and it's kind of bouncing around. If we look at this, we're going from like 164 to 170. These really aren't like scientific values. They're really just the kind of the resistance or the voltage that we're reading from that pin based on that photoresistor. So what I'm going to do is I'm going to put the flashlight on there, and we can see that was even enough to trigger it. Okay. Then I'm going to put the laser on it. Let's see what happens there. Okay. So great. So we can see that right here we're getting these values here that are up above 400, and then that's kicking that off in this case. So this is a great way for the students to think of like a calibration exercise, and you can change that value around, and you might find that maybe your laser pointer or the characteristics of your office and lighting or maybe a window next door where you're actually going to have to change that value in your sketch where you have that value 400. So this is a good place where your teams can get together and the students can look and they can actually calibrate what is that laser doing to that photoresistor, and is it going to be enough to trigger it. Now in our case, what we want to do is actually have it be kind of the reverse logic. We want it to be on until that beam is broken. So I'm going to go ahead and load this new sketch on here. So this is compiling this code, it's flashing it, and then it's going to send that new piece of code onto the Arduino. And when it does, okay, now it's just on. And it's kind of interesting too. If we hear it, it's kind of making like a skipping sound. Let's listen. And it's happening at a frequency of about every second. And the reason it's happening is actually because we're printing that value out here. And so if you don't like the skipping sound in your thing, you can actually take this and you could comment that code out. And we could run it again and that skipping sound would go away. Let's give that a try. It's kind of interesting. Because what's happening in this loop is it's just running again and again, and it's actually taking that resistor. So now we hear just kind of a smooth sound to that now. And it still works, okay. When we get the laser beam on there, we can see that it's turning that sound off. Great. Okay, so I think the next step is, let's go ahead and, so it's pretty loud. We'll turn that off. Actually, it's right here. Great. Okay, so with the Arduino sketch above, describe when the sound plays. So this is kind of that investigation and research, and let them figure out some of this on their own, I think is important too. I think it's great when, rather than explaining what they should be getting, is actually ask them questions. And then if somebody has it right, say, you know, how did you figure that out? And maybe get a good discussion amongst the students. What do we need to fix this to actually have this operate correctly? And that's what we did before, where we changed this greater than into a less than sign to change that logic. And then we got some examples here in the code here. Okay, great. And why? Okay, so what I'm going to do here is, let's go to the setup side. So this would be some of the engineering side of this whole thing. And what I'm going to do is I will change to, I'm going to change to a video screen so you can see me set this up. So I'm going to stop that. And let's see if I can get, okay, let's see if we can figure this out. Okay, great. So we have the circuit here. And then right here, laser beam. And this is kind of a crazy stretchy arms for soldering, but this is where you might use duct tape and poles and popsicle sticks and anything you have in order to kind of secure this. Now, it's not trivial to actually aim a laser at a small distance here. Let me go ahead and get my circuit working. Okay. And let's see if we can get this. Let's see if we can get this aimed. Okay. Let's see if we can get the distance. Okay, wow, that was a lot faster than I thought I was going to get that. So hopefully you can see this right here. It's trained, this laser beam, straight on here. And so this could be set up in the hall, and then when somebody walks, it goes off. Yeah, fun. You've captured them. Okay, let's see. So we move that back now. Obviously, whoa, that's fun. Get a little vibration. Cool. So you could take it up one more notch and actually take up and add mirrors and bounce this once. Maybe you have somebody that can take the challenge and bounce it multiple times. And then I think it's also, I'll go ahead and turn that off. Then I think also it's fun where maybe you set up a challenge and people set up rooms, and then maybe people try to get across different type of alarm systems and maybe turn it into some gamifying type of event. So I wanted to keep this kind of focused, and I think right now we can move and maybe answer some questions that might be in the chat. So what type of questions do you have about the setup or the why behind it, or anything I could help with? While you guys are typing in the chats, go ahead and type in a couple of chats. And what I want to show too is I'll take a quick second and show you a few of the other lessons that I think you might find interesting too while you queue up some questions. Okay, so I talked about it before, but sound waves. So we got a great lesson on sound waves having to do with that piezo buzzer. Have the ability to kind of look at wavelength and play with that with actually creating sound waves with that little piezo, and then actually playing something. Maybe you have some musicians in your group that can have some fun with that. The other one is kind of neat, is this exoplanet hunter, and this one, let's see if there's a model in here somewhere. Maybe I'll find it. Yeah, so kind of neat is the way that they're actually finding these little planets is they're looking with a light sensor, and they look at the dip of light coming from these distant suns or stars, and they can derive if this is a planet orbiting, and then they can understand kind of how big it is and how far away it is, and all kinds of different really interesting things from just a tiny blink of light. So you can actually set up a model of this in your classroom. And then laser timing ramp. So if you want to do some physics experiments here, you can actually set up a timing ramp. So you can do this with like Hot Wheels, or there's like a build your own type of little car type of exercise. And I think now what we'll do is go into some Q&A.
Okay, question. Are the online lab questions available for the students? Can we set up a virtual classroom where we can monitor the students' answers?
Oh, okay. So that's where you might have to use maybe one of your other tools in your tool belt for that one. So we don't really have a good way to have like those to facilitate that. So you might have to come up, be a little creative on that.
Yeah, I would recommend maybe having your students write the answers to the questions in their science notebooks or something.
Okay.
Yeah.
Okay. Perfect.
What's the recommended group size for laser?
Yeah.
Alarm?
So a lot of times through our experience in the classroom, I think 2 is a really good ratio. But with this, where there's a lot of engineering also, I think 3 can be great. Maybe even a little bit more because of you actually have like a code and the wiring, and then the physical side of actually placing the laser in the photoresistor. So I think you could actually have several. Just so everybody knows too, we are recording this, so if you missed something or you want to share this with something, I'll be link that's coming out.
If I want to replace a regular resistor with a photoresistor, do I have to modify the code, or can I just simply swap it out?
Yeah, great question. No, you can simply just drop that in. There's nothing that you have to change with the code. Like that one example where I changed the photoresistor, the resistor with a photoresistor, and also when I put the LED in instead for the piezo, those just kind of fundamentally work along the same principle, the same code, so you can kind of interchange those. That's a great question. Well, I know we wanted to kind of keep this focused because I know people are busy, and we really appreciate you visiting today. It looks like we might have one more question, Brad.
We have one more.
Sure.
This is a great question. Any ideas on using this in an algebra or a geometry class?
Yeah. So Lindsay's our in-house mathematician there.
I am, and I'm kind of thinking about, we have a lesson that kind of goes with this, that goes with the same concept called the laser particle counter. And I think that would be more in line with the math, because you're actually collecting data. How many times do you break the laser beam? And you could do some pretty fun like rates of change activities, I think, with that, logging the data and how fast the laser beam is getting broken, how many times you're counting the laser beam that's broken, things like that. Can you bring up that lesson really fast?
Yeah. Okay. Here.
Show that one.
Sure.
And Jennifer would like to know if the kit comes with a laser shark.
Not
I love it.
yet.
There it is.
Laser particle counter. Yeah.
Laser
And in
particle
this case, the particle is a big rolling block, but that could be, you know, whatever you
Yeah.
want to do to break the beam.
Totally.
So yeah, if you go under search for other lessons and just type in particle, you'll see that come up.
Great question.
Great. I think that's it. Well, thank you very much, everybody, for attending today, and have a great day. And thanks again for ASE for supporting our Astro School. Take care, everybody.